Hi, I wanted to talk today about some of the impacts of climate change and some of the realities that we have to deal with as we move forward into a warmer future. I think it's important to get started looking at the data. This is the global surface temperature from the late 1800s as collected by NASA, and there are many other climate research groups around the world who corroborate this data set. As you can see, over the course of this little movie, we see an overall warming surface temperature to Earth. The Arctic region is warming faster than any place else. Continents are warming faster than the ocean. And there are some cooler locations. The North Atlantic is one of the coolest locations, and also portions of Antarctica. The same data can be plotted as year-by-year averages. What you see here is, again, from 1880 up to present day. And generally speaking, the surface temperature of the planet is warmest during years that are El Nino years, and coolest during years where there are either large volcanic eruptions or La Nina years. And we want to pay special attention to super El Ninos. We had one in 1998, and we've just finished one in 2015, 2016. These super El Ninos have been forecast to grow in strength and frequency. And what we have seen historically of a super El Nino every 20 years, roughly, is going to be occurring twice as often with super El Ninos roughly every decade. Here in Hawaii, these super El Ninos are when we experience some of the greatest impacts from climate change. We see extremely high sea surface temperatures, which of course are very damaging to our corals and lead to coral reef bleaching. We have extreme episodes of rainfall. In 2015, we had record-setting rainfall on a number of days. We also had record-setting heat waves in August and September, particularly. During large El Nino events, we get especially large waves that arrive from the North Pacific, and these can be very damaging to coastal development, especially our roads. So overall, the El Nino-La Nina process is important to keep our eyes on because it represents climate variability, that is, variations from a long-term trend that can lead to negative impacts here in Hawaii and in fact around the world. So climate change is the result of carbon-based gases that are released when we burn coal and oil and natural gas in order to derive energy from them. There are also other types of gases that trap heat like these do, known as the fluorocarbon gases, and also ozone, which is not the ozone layer, but is a gas that is released from fertilizer and also from some of our transportation activities. The worst one, though, the gas we're most concerned with, is carbon dioxide. Carbon dioxide may stay in the atmosphere for centuries to over 1,000 years. And like all greenhouse gases, what it does is trap heat that is rising off of Earth's surface or from the atmosphere itself. This heat originally comes from the sun, but it comes in a different wavelength. The wavelength that is radiated by Earth is known as infrared. It's a longer wavelength, and carbon dioxide and other greenhouse gases trap this, preventing some of it from escaping to space. The anthropogenic greenhouse effect is what this is known as, and it's analogous to having too many blankets on your bed at night. If you're a little cold and you throw a blanket on to warm up, that's fine, but if you throw too many blankets on, you get too hot, and the buildup of these greenhouse gases in our atmosphere is very analogous to that. And in fact, we are warming the atmosphere to the extent that so far we have increased it 1 degree Celsius, or about 1.8 degrees Fahrenheit. These greenhouse gases come from a number of sources. One is when we drive cars, buses, trucks, as well as airplanes and ships that here in Hawaii bring most of our goods and services to us. So the transportation sector is an important source of greenhouse gases, as is the industrial sector, burning fossil fuels to power manufacturing. And we have a number of companies that have worked hard on reducing their reliance on fossil fuels, such as Intel, Apple, and Microsoft, major global companies that now are powered 100% by renewable energy in the form of wind and solar energy and hydro electricity. Electricity and heat production are another important source of greenhouse gases. The electrical plants around the world generate their electricity by burning coal and oil in order to boil water, which turns to steam and turns a turbine that produces electricity. There are other ways to do this, of course, and our reliance on coal and oil is something that we are moving quickly away from. But as you'll see later in the talk, unfortunately, not quickly enough. And we are engaged in industrial scale agriculture around the planet to feed the growing human population. We are deforesting large regions of the planet's surface in order to grow more food. This type of land use, unfortunately, removes the trees and plants in old growth forests that store a lot of carbon that would otherwise be in the atmosphere. And certain types of agriculture, such as growing livestock, raising beef, industrial protein, for instance, are very greenhouse gas intensive. So as I mentioned, the average temperature of the planet has increased roughly 1 degree Celsius from what we consider to be pre-industrial time over 150 years ago. And although that may not sound like it's a very high increase, it's analogous to your body temperature. If your body temperature increases 1 or 2 degrees Celsius, and you can roughly double that for Fahrenheit, so if you run a fever of 2 degrees or 3 to 4 degrees, you feel pretty bad. At a fever of 103 or higher, you go to the hospital. That's only a couple of degrees increase in your body temperature. It represents a fundamental change in the energy of your metabolism. And 1 or 2 or 3 degree change in Earth's atmosphere represents a fundamental change in the energy of our climate system. Because of this rise of temperature, we have seen wildfires in Western North America increase 9 times. We now see that 1/3 of the world's population is exposed to deadly heat waves. And every year, someplace on the planet, we hear about fatalities resulting from heat waves. Extreme rainfall has increased 12%. This is because warmer air holds more water vapor. And when it precipitates, when it rains, there's more rain that comes out. And in order to get that water vapor up into the air, it actually leads to drying of the planet's surface. So we actually have, ironically, increased extreme rainfall events separated by long periods of drought. This speed up of the water cycle leads to weather disasters of various types, and they have increased twice. They have doubled. Weather disasters have doubled over the last 2 decades. And the insurance industry is paying attention to this. This graph shows losses that need to be covered by the insurance industry since 1980. You can see there's a long-term rise. And these losses are due to storms, floods, heat waves, droughts, and forest fires, all related to Earth's climate system. And so climate change is causing our world to get more and more expensive. Climate change is also forcing ecosystems out of the place where they evolved. Nearly half of all species, both in the ocean and on land, have now had to shift their location due to climate change in order to find cooler areas or to recover the rainfall or the seasonality that they are comfortable with. Because of human development and because of changes in soil conditions, as you move upslope in a mountain system, for instance, it's not always possible for ecosystems to shift. For instance, ecosystems in the upper regions of a mountainous area have no place to shift to. They can't go up any higher because they're already as high in elevation as the land will allow them. Here in Hawaii, our ecosystems at the upper reaches of our watersheds are a key element of producing water. They interact with clouds. They capture that moisture and they drip it into the ground surface. This cloud drip, which comes from our upper watershed forests, can account for nearly 50% of the water that we drink. And the warming of the air and the changing of rainfall here in Hawaii is stressing these ecosystems. Something that not many people are aware of is that as we grow our basic cereals, the soy, maize, rice, and wheat that constitute major forms of protein for the human population, they become less nutritious and less rich in protein as CO2 levels in the atmosphere rise. We see a decrease in iron and zinc and B complex vitamins in these basic food groups, so that even if we might be growing more food towards mid-century, it becomes less nutritious. And the net result is that there's lower yield of these foods needed or available to feed the rising human population. The oceans are suffering enormously. 93% of the heat that has been trapped by anthropogenic greenhouse gases is actually stored in the ocean. If the oceans had not taken up this heat from the atmosphere, Earth's surface would already be too hot for life. But in taking this heat up, the oceans themselves have gotten warmer. They have also absorbed carbon dioxide that we emit through greenhouse gas emissions, and so the ocean's pH is lowering. They're becoming more acidic. And as the oceans warm, they hold less dissolved gas, which means they hold less oxygen, and they become more stratified or stable, if you will. There's not as much mixing with the atmosphere, and then the surface layers of the ocean don't mix as much with the lower layers. So there's not as much oxygen getting pumped into the ocean. Overall, since 1950, the oceans have declined 2% in their dissolved oxygen. And a very important consequence, especially here in Hawaii, of warming ocean and acidifying ocean is that it stresses our coral reefs. Corals will bleach or they will lose an important symbiotic algae that provides them with oxygen and carbohydrates for food. And in that bleaching process, they lose their color because the beautiful purples and yellows and greens of corals actually comes from the symbiotic algae that lives in the coral polyp. As these symbionts are ejected by the coral polyp because the water temperature is too high, the corals bleach, and they can only survive bleaching for a few weeks to a month or two. And in coastal waters such as Hawaii and elsewhere around the world where we are adding excess nutrients by our sewage disposal, we actually have a problem with another type of algae, a noxious fleshy algae, which very quickly can take over the coral reef within a few weeks. And that disallows the coral from regaining the symbiotic algae that it has lost. We are melting the cryosphere. The cryosphere is the world's ice system. Greenland, Antarctica, the mountain glaciers of the world, they are all in a state of severe retreat. In fact, portions of West Antarctica, which you see on the left side of this image of Antarctica, which are colored dark red, those are glaciers that are already past a tipping point. They are in a status of unstoppable retreat. So even if we were to stop greenhouse gas emissions right now, these glaciers would continue to retreat, and they are going to lead to several meters or well over 6 feet of sea level rise, although hopefully it will be played out over centuries. If we can't slow our greenhouse gas emissions very quickly, the loss of these glaciers may play out this century, which would lead to catastrophic sea level rise. In fact, Research groups, especially government agencies here in the United States, have forecast that sea level is likely to rise between 1 and 4.3 feet by the end of the century. The reason that this image shows sea level rise is because when it rains in a low-lying coastal community such as Honolulu, and it happens to be high tide, salt water floods up into the drainage infrastructure where rain is meant to be drained off the land surface. And if our storm drains are flooded with salt water from rising sea level, the rain has nowhere to go, and we end up with situations like this, which occurred in the major El Nino of 2015, leading to flash flooding in urbanized areas. Now, all that is rather distressing, but there is good news. The United Nations has been leading an effort to organize the world into cutting their greenhouse gas emissions. And they recently, in 2015, the world's nations signed a treaty to stop warming at 1.5 degrees Celsius, and if possible, at 1.5 degrees Celsius if possible, but if not possible, then certainly below 2 degrees Celsius. Unfortunately, nature has the last word, and there is a concept known as the carbon budget. When you put a certain amount of carbon into the atmosphere, you are committing to a certain temperature. And currently, we are dumping over 40 billion tons of carbon into the atmosphere every year. And to that, we would add other types of greenhouse gases that are not carbon-based. But overall, our annual emissions are on the order of 40 to 41 billion tons per year. And since 1880, we have released 560 billion tons of carbon into the atmosphere that is still there. Well, if we want to stop warming at 1.5 degrees Celsius, as per the Paris Treaty, we can emit no more than 593 billion tons of carbon-based greenhouse gases in order to stand a 2/3 probability of stopping warming. And obviously at over 40 billion tons per year and already 560 billion tons in the atmosphere, we have missed the opportunity to stop warming at 1.5 degrees C. Emissions must stop next year, in the year 2019. To stop warming at 2 degrees Celsius, no more than 790 billion tons of carbon equivalent can be released to the atmosphere to withstand a 2/3 chance of stopping the warming. And that means we have on the order of less than 15 years to stop all greenhouse gas emissions. Modelers of climate have identified that we are right up against the last opportunity to decrease our greenhouse gas emissions and still stand a reasonable chance of stopping warming at 2 degrees C. If we can peak our greenhouse gas emissions and bend the curve, as they put it, so that greenhouse gas emissions globally decrease beginning in 2020, which is only a year or two from now, we stand a chance of stopping warming at 2 degrees C. Unfortunately, the year 2017 saw a rise, an uptick of roughly 1.5% to 2% in global greenhouse gas emissions. In the years 2014, 15, and 16, it looked like we had stabilized our greenhouse gas emissions around the planet. We were all hoping to bend the curve in 2017 with a decrease, but instead, because of economic growth in India and China, we saw a rise in carbon dioxide emissions. What every nation pledged in the United Nations Paris Accord in the year 2015 is really only 1/3 of what we need to stop warming at 2 degrees C. And we see signs around the planet that we are still far away from decreasing our use of coal and oil. For instance, there are 4 new oil refineries which are on the drawing board for the nation of Iraq. Exxon is investing $20 billion in the US Gulf Coast to build new refining facilities where petroleum taken out of the ground is turned into cleaner oil and gasoline. Chevron is spending $54 billion to build a natural gas facility in Australia. And because of the Fukushima earthquake, which destroyed the Fukushima nuclear power plant, and drove the people of Japan away from liking the idea of nuclear power. Japan has actually opened 8 new coal power plants in the last few years, and they have plans to open 36 more in the next decade. So this and other signs around the world show that we are not yet ready to decrease our greenhouse gas emissions. In fact, if you look at primary energy consumption from 1965 up to present day, 2017, oil still makes up roughly 1/3 of all the fuels that we use to generate energy. Coal, 28%, natural gas, 23%, hydroelectricity, 7%, and it has not increased, nuclear power, 5%, and renewable energy from solar and wind is still only 4% of the market share in producing energy worldwide. We need that to increase dramatically. Unfortunately, the U.S. Energy Information Administration and the International Energy Agency and a number of other energy economists and experts all predict that there will be rising global GDP. This will generate an increase in energy demand, largely because India and China want to join the middle class. This increase in energy demand will be met with oil and natural gas. Renewables will meet part of it, but as oil rises to meet this demand by the year 2040 and renewables rise to meet this demand, the market share of the two of them will stay the same. Overall, it's likely, and in fact it's forecast that we're going to see over 10% rise in greenhouse gases over the next 2 decades. Thus, we are on a pathway to global warming of 3 to 4 degrees Celsius. A number of research papers point this out. This particular paper calculates that we're looking at a median of over 3 degrees C by the end of the century. A world that has warmed that much is going to have a global scale refugee crisis. Sea level will be on the order of 30 to 50 feet higher, although it will take several centuries for that to play out. There will be disruption in the food system of the world, extreme weather disasters. Our ocean will continue to be damaged and ecosystems there broken. And many tipping points, that is, natural systems that will be tipped into a new state that cannot be recovered, like the West Antarctic ice sheets, are going to materialize. Ironically, this will all take place in a world of solar panels, windmills, electric cars, and clean air. Now, we can be extremely proud of Hawaii. We have pledged as a state to have 100% renewable energy by 2045, and we are well on our way to doing that. We already use renewable energy for over 26% of our energy in the state. Solar energy and electric cars have increased. This shows the rise of photovoltaic systems across the state of Hawaii from 2011 to present day, with over 74,000 solar panels or individual installations of solar panels. And this shows the rise of electric cars. We're now up over 6,800. In fact, we're over 7,000 electric cars in the state. All of this is very strong and needs to, in fact, accelerate. We see a decrease in greenhouse gas emissions from HECO, our energy utility, as much as 20% decrease. And we are the first state to announce that we will be carbon neutral. Act 15 was signed into law by the governor in 2018. And there will be a greenhouse gas sequestration task force created to map a pathway to zero emissions by 2045. Act 16 directs the Office of Planning, a state office, to create a carbon offset program. That is, farmers and other activities that take carbon out of the atmosphere can earn money on this activity. And this allows Hawaii industries to buy carbon credits, so we could sell our carbon use activities to other states as a form of income. Act 17 was also signed into law, and it requires all applications for building permits or development permits to consider sea level rise in their plans. The City and County of Honolulu has an Office of Climate Change, Sustainability, and Resiliency. In fact, this was voted in 2015 in a referendum by the citizens of Oahu. This office is moving forward very quickly in electrifying the fleet of vehicles, in getting all other agencies and offices for the City of Honolulu to become carbon neutral and to focus on resiliency and sustainability. And the 5 most important steps that you can take are rather straightforward. Reduce, reuse, and recycle. Vote climate change. Even today, we see a race for governor that is not emphasizing climate change, despite the fact that it poses enormous threats for the state of Hawaii. We need to communicate to our friends, family, and the public in general that climate change is a serious issue. We need to decarbonize our diets and decarbonize our transportation by flying less, using more mass transit, public transportation, driving electric vehicles, etc. So let's end with this video that talks about a global carbon law, which basically guides us to cut our own carbon footprints by 50% each decade.
Humanity is very fortunate. Our home, planet Earth, has been swinging in and out of ice ages and warm periods over the past million years. And it's only the past 12,000 years, when we left the last ice age, that we enter a unique equilibrium of planet Earth, the Holocene, that has enabled the world to develop as we know it. It's not too cold and not too warm. In fact, it's staying within the narrow band of a maximum temperature variability of ±1 degree Celsius. And the drama is that now we have so much scientific evidence that we're pushing humanity out of this Goldilocks equilibrium. This is a crisis where we can no longer exclude risks of catastrophic tipping points. We've shifted over from being this small world on a big planet to today being a big world on a small planet. We know that we are facing at least 1 meter sea level rise this century, that heat waves and droughts and floods are critical threats that will occur, which in turn risks stability in societies that can tip over into refugee crises across the world. We need to bend the curve of emissions no later than 2020 to stand a chance to surf down an incredibly steep slope of reducing emissions and leading to a decarbonized world economy by mid-century. But the good news is we're starting to see the first indications that the exponential rise of emissions is starting to level off. We're starting to see that renewable energy systems are entering the rapid phase of exponential adoption in the world. We can see that delivering on Paris, bending the curve, can go from a necessity to also being something that is doable. Now, all of this translates into a global carbon law. For us to succeed with a decarbonized, desired future for humanity, we need to halve emissions every decade. And this halving emissions every decade becomes a golden rule which is applicable at any scale, as an individual or a household or a company or nation, which then needs to add up to the world as a whole. This is the golden rule that can enable us to stay in the Goldilocks equilibrium. It is what gives us a chance to succeed in transforming to a stable and resilient planet that can support the development of humanity on Earth.